Can you visualize how your cam might work in an automata mechanism? To test and analyze the linear motion created by your cam, you can simulate the motion using your CAD computer model. By placing and properly constraining your cam computer model within an assembly model, you can see how a real cam might interact with other parts of an automata mechanism. First, open up the Automata simulation assembly file. The assembly includes computer models of a box, similar to the one you manufactured earlier, a follower, a guide, and an axle handle component. These parts have been assembled in this assembly file using assembly constraints to replicate realistic part interaction. You'll learn more about CAD assemblies later in the course, but for now we'll walk through the specific assembly constraints you'll need to simulate automata motion. First, we need to place the cam into the assembly. From the Assemble tab, in the Components panel, choose the Place tool, and then select your cam file from the list. For this example, we'll use a file called HexCamTest, and then choose Open. Now move your cursor into the graphics window and you'll see the part displayed. If you click, you'll place the part in the orientation shown. However, you can change the orientation of the part before you place it by right-clicking and then choosing to rotate the part about one of the primary axes. In this case, it'll make assembly a little easier if we rotate the part 90 degrees about the y-axis. So I choose Rotate 90 about the y-axis, and then I left-click to place the part. You can click again to add another identical part if desired, but in this case we only need one cam, so right-click and choose OK. Now add the assembly constraints to properly constrain the motion of the cam. First, make the mid-plane of the cam to the plane that passes through the center of the follower. To apply an assembly constraint, in the Assemble tab, choose the Constrain tool in the Relationships panel. This will open up the Place Constraint dialog box. Choose Mate in the Type box, and then select both planes in succession. Again, we want to mate the mid-plane of the cam to the plane that passes through the center of the follower. And then choose Apply. Next, mate the center axis of the hole in your cam to the center axis of the axle. So I've already chosen Mate. Click on the center axis of the cam and the center axis of the axle and choose Apply. Finally, so that the cam can rotate with the axle, mate the work plane that you named Angle of Rotation Cam to the work plane that passes through the axle and handle. So this is the work plane that you named Angle of Rotation Cam. Choose that, and then the work plane that passes through the axle and handle. And then choose Apply. Now close the Place Constraint dialog box and try to rotate the axle using the handle. If you place the constraints properly, the cam should rotate with the axle. Now let's place a transitional constraint to force the follower to ride along the edge of the cam. You'll do this by placing a transitional constraint between the outer surface of the cam and the underside of the follower. But you can see it's a little difficult to see the parts with this box here. Before we add the transitional constraint, let's turn off the visibility of the box so that we can see the cam and the follower clearly. To do that, find the box in the browser, right-click, and uncheck visibility. Let's also turn off the visibility of some of the work planes in the same way. In the browser, find your cam and expand the children. And we're going to turn off the visibility of the work axis and the work plane that's unnamed. We'll leave the angle of rotation work plane visible because we'll need that later. Now, back to the transitional constraint. Again, from the Assemble tab, in the Relationships menu, choose the Constraint tool, and then select the Transitional tab. You have only one type to select from here. A transitional constraint specifies the intended relationship between typically a cylindrical part face and a contiguous set of faces on another part. Faces are contiguous if they share a common edge or border. We want to force the cylindrical bottom face of the follower to ride along the contiguous faces on the outer edge of the cam. In the selections box, the first selection is already highlighted. Choose the curved surface on the bottom of the follower first. So I'm going to rotate the assembly and choose the surface on the bottom of the follower first. The second surface is the outer edge of the cam. And then choose Apply. And close out of the Place Constraint box. And I'm going to zoom out and look straight on at the cam. Let's test it by rotating the handle, and you'll see that the follower follows the edge of the cam. That's exactly what we want. Now we can insert an angle constraint to control the angle of rotation. To do this, turn on the visibility of the follower work plane called Angle of Rotation Follower. Go to the follower in the browser, open the children, and turn on Angle of Rotation Follower work plane by checking visibility. You can turn off the visibility of the mate with midplane of cam work plane too. Finally, impose an angle constraint between the angle of rotation cam work plane and the angle of rotation follower work plane. To do that, go to the Assemble tab, Relationships panel, Constrain tool. Now we're going to choose an angle type and choose the Directed Angle Solution. And then click on the work plane on the cam and the work plane on the follower and choose Apply. You'll notice in the browser that this last angle constraint is now 0 degrees. It defaults to 0. You'll no longer be able to rotate, let's get out of this dialog box, you'll no longer be able to rotate the axle and handle or the cam because that angle is now forced to 0. However, we can adjust the angle of rotation by right-clicking on that angle constraint, choosing Edit, and then changing the angle setting here. For most cams, using a 45-degree interval will likely be sufficient to provide a reasonable motion graph, but for the hexagon cam, you'll need to use shorter intervals in order to record the maximum height of the follower. So I'm going to use 30 degrees here and click OK. And you'll notice that the cam is now moved 30 degrees. Let's try it again. I'm going to edit and I'm going to change the angle to 60 degrees. Notice that the cam is moved. To make reading the measurements easier, you may want to turn on the visibility of the top of the follower and the bottom of follower work planes. In order to do that, in the browser, go to the follower part, right-click on the top of follower work plane, turn on the visibility, and the bottom of follower, turn on the visibility. To take measurements of the distance from the center of the axle to the top of the follower, there's a ruler provided in the assembly. The ruler is turned off, but we can turn the visibility of that ruler on as well. Find the ruler in the browser, right-click, and click on the visibility. You can adjust the ruler so that it is initiated. The initial point is at the center of the axle, and as you rotate the cam around, you can read the level at the top of the follower. The work planes that you just turned on should help you better visualize the measurement for the top of follower and bottom of follower measurements.